Hello everybody, and welcome to my second report from the high entropy zone. I've actually put a reasonable number of hours out in the workshop this weekend and made some progress on the Marini club bike. I've mostly been doing electrical work, replacing cracked sleeving and repairing one or two previously poorly done crimped on end repairs, and I'm going to be changing some of the switch gear to make it easier for riders, but I've done some machining. It needed a chain and sprockets, so I machine a sprocket blank, and the video is on the PC behind me, and most of the editing's done. So once I've finished recording this little intro, I shall put that in, and hopefully it will be uploaded tonight. If not, it'll go up on Monday. And as usual, thank you very much all for your likes and subscriptions and comments, and please stick around, and I hope you find it interesting, and see you all next time. Okay, this is the rear sprocket of the Marini Riders Club club bike, and it's not seriously worn, but it is worn. If I zoom you in, you can see that the teeth aren't asymmetric or hooked, and this isn't a particularly bad example. Sometimes they're really badly hooked, and on one occasion I had a bike to me that the rear sprocket no longer had teeth, it only had gums, and made the most appalling noise as someone opened the throttle and the chain was skipping. That required a gearbox rebuild because of the strain it put on the gearbox output bearing, and likewise the bearings in the sprocket carrier, and indeed the rear wheel. However, this sprocket is not seriously worn, but is due for replacement, and you can get the sprockets in this size with the correct bolt pattern for the hub, but it's a lot cheaper to buy a sprocket blank, and in any case I'm going to convert from a 530 chain to a 520 chain, and the reason for doing this on the Marini is, one, the 530 is overkill. I've got the same size chain on my 100 horsepower 1000cc Yamaha that weighs over 1/4 of a ton. The other reason is the narrower 520 chain I can then go to an O-ring or X-ring chain, which it's got longer life and lower maintenance. If you fit an O-ring chain with a 530 sprocket, you can be putting the crankcases in danger. So I've got several of these to do. There's our cleaned up sprocket carrier off the club bike, and because it's an early bike with wire wheels and drum brakes on both wheels, it has a 160mm rear drum, and this is the sprocket carrier for the 160, and this is a later sprocket carrier from the 180mm rear drum, which was fitted to all disc braked bikes, whether they have a drum on the whether they have wire wheels or whether they have the cast alloy wheels. They went to a 180mm rear drum. Before that, only the Sport had the 180, and this sprocket carrier was used even on the disc braked alloy wheeled bikes. They just changed the other side of the wheel. Anyway, you can see that there's quite a difference in the mounting spigot diameter. This is, as I recall, a 110. Yeah, and this is a 90. You can also see that this is a 5-bolt pattern and this is a 6. I've got to do this on my own bike. The chain's been on there for about 10 years and is getting pretty worn, and is due for replacement. I'll take the opportunity to do a 520 conversion, so I've got a couple more blanks. I'll do the bolt pattern by a different technique because it's 5 bolts and therefore I can't use the super spacer, which I can use for this one. So the first thing I'm going to do is I'm going to just superimpose the sprockets on top of each other and draw myself a guide circle so that when I clamp it down on the mill table I know where to put the parallels underneath so they won't be in the way when I bore the sprocket out. So there we go. I'm starting to set the sprocket blank up on the mill here, and I've got some parallels, and by looking at the line I've drawn underneath I know if I position them even with the top of the teeth, then I've got clearance underneath to bore through. So I'll get the clamps set up reasonably close. Always remembering to get the clamps pointing slightly downhill so that they're clamping at the tip end here. We're nice and secure, and we've got the clearance in here for the cutter to go through. So I need to get the blank centered up with the spindle. So I'm going to use my very nice Sean 3D taster. So we'll obviously eyeball roughly into the centre to start with. And I'll tell you what, I'll grab the other camera and we'll have a look at the gauge as I do this. Okay, that looks pretty good now. So if we wind over and we're watching both needles, and at 0 in X, and at 0 as well. So I've used the X-half function, and we're back to centre, and I'll just lock that axis for the moment. We'll zero out Y. And I'm getting a measurement on the display of fractionally over 38 millimeters, giving us our nominal bore in the sprocket. So again, we can do Y half. I'll come back to 0. And we'll check in the other axis. When we come out to 0, we should be on 19 millimeters, because that's half of 38. And we are, so we can come into 0, 0, and we're all centered up, ready to do the boring. Now, because of the relatively large diameter, I'm actually going to be using my cheap Indian sober boring head, but with the extended horizontal holder that I made some time ago. I've done this job before, and I know this works perfectly well. And this is just a simple block welded on. Get the head wound out to sensible starting position. I'll bring the knee up a little. Lock the slide, and I'm going to go and find my quick depth stops so I can use the auto trip out. Okay, let's take a pass through here and see how we do. Take a decent sized cut now. Start off with a 40 thou cut. That went through very nicely. So we'll take 50. There's 25 aside. And we can easily take more than that. Let's see what happens if we go up to double. Obviously this is going to take quite a few passes to remove this material, and there are other ways of getting it out. If I could trepan it or faceplate mounted in the lathe and face groove it or something like that, but this is the convenient setup. So I'm just going to plough on through, and we'll come back when I'm nearer to size. We're about a third of the way through, and I'm up to been steadily increasing the depth of cut. So I'm now up to 100 thousandths of side, 200 thousandths overall. And I've been gradually winding the spindle speed up, despite the cut getting bigger. And I'm approaching the point where I'll want to reset the head and put in the extension. They're pulling off rather stringy chips, but the finish in there's really pretty good. I'll zoom in for a second. See, that's not at all bad. And it's a high-speed steel boring bar that I diamond honed before we started. So I think we'll take one more pass, then I'll probably put the, I think I can then get the extension in. This is, it's not WD-40 by the way, it's duck oil, which actually contains quite a bit more lubricant, because WD-40 is nearly all solvents. Right, I think I'll reset the cutter now, see if we can get that in. We're now out to the point that I've got the slide engaged with the extension in place, and I'm going to start reducing the depths of cut, because obviously the horsepower requirements have gone up for this larger diameter cut. So this was a 50 thou total on diameter, and I've changed the belt speed. I've brought the speed down a notch. It's singing just a little, but actually the finishing there is pretty good. I think I might try 100 cut if I could hang on to my Allen keys. It's cutting okay. Finish still isn't bad. I think we can go at it at that rate. Just going to make sure the extension bar is tight. I'm just going to keep an eye on diameter. We're out to 90mm, so we've got another 20mm to go in total. I'm getting down to the last few cuts, and still running this at pretty high speed, and if I keep it well lubricated I'm getting a decent cut, but it's getting smoky. I want to get a reasonably accurate measurement on this bore, and you know, commonly you'd use a telescopic or snap gauge, but there's no depth in here for me to be able to do a sweep on to get an accurate reading. So instead I'm going to use an inside spring caliper, and I'm just feeling for the loosest point, and then so in the middle of the loosest point, and I just want to be gently rubbing, and then I'll get out the big micrometer. And a while back I acquired this 0 to 6 inch Mitutoyo set, and I've got to install the anvil and get the setting standard out of its packing wax, the hot dip wax, get it calibrated, and then I can take a reading. We're using the calipers and the big digital micrometer. I'm getting a figure of 36 thou under from final dimension, so I'm going to take 15 for starters. I rest the jaws, the legs on the face of the sprocket so they're the same height, and I can probe backwards and forwards and feel for the middle of the bore to get a dimension. It looks like I've got 20 thou to go. That's 10, 20. I think we're spot on our 110mm. Pull this out, and if we have to, we can always recenter on this ball. And yes, that is a chicken you can hear in the background. Because of the smoke, I've got the workshop door open. And we've got the hub. And that is just it'll take a little bit of a squeeze to go on. So that's an absolutely perfect fit. I'm going to use the super spacer to do the bolt pattern. So the first thing I'm going to do is get the spindle aligned, and it doesn't have to be too critical. And I can do it by eye really, and by feel. What I've got is I've got an end mill held in the chuck, and it's got a centre on the back, so we're centred well enough for the job. Now I want to be positioned so that the 6 holes all miss chuck jaws. So in order to do that, we'll choose that as a starting position. I just want to get the sprocket up, and just as a aid to preventing errors, that's a fairly decent set of marks. Okay, we're all set up. I've come out 62.5mm, which gives us a 125mm PCD, and we've got a spotting drill in there. So we'll go ahead and spot all these positions, then drill them 7mm clearance. So that's 6 holes. And I just need to deburr those, and I'll drop some bolts through and see if they line up properly with the hub. There we got the sprocket on the hub. And the bolt drops in perfectly at every location. Job done. Time to get it reassembled and back on the bike.